Meta just released Llama 4 and its headline is its 10 million token context window. They released 2 open models and announced a third. There's Llama 4 Scout and Llama 4 Maverick. These are the first open-weight natively multimodal models with that unprecedented context length, and then they are previewing Llama 4 Behemoth, what they claim to be one of the smartest LLMs in the world, beating GPT 4.5, Sonnet 3.7, and Gemini 2 Pro on several benchmarks. Hit that subscribe button and let's jump in. Here's the breakdown of the models they have. Let's go up the list and start with Llama 4 Scout. Llama 4 Scout is a 17 billion active parameter model with 16 experts. It's the best multimodal model in the world in its class, and it fits on a single H100 GPU. The most impressive thing though is the industry-leading context window of 10 million. That equates to roughly 5 million words. It's going to be absolutely awesome at multi-document summarization, parsing extensive user activity, and reasoning over code bases. It demolishes models like Gemma 3, Gemini 2 Flashlight, and Mistral 3.1 across a ton of benchmarks. You can see it's best in class on image grounding. This means that it's able to align user prompts with relevant visual concepts and anchor model responses to regions within an image. Overall, that just means it's going to better understand the user's intent and localize objects of interest inside of an image. Llama 4 Scout also exceeds comparable models on coding, reasoning, long context, and image benchmarks, and offers stronger performance than all previous Llama models. Next, we have Llama 4 Maverick. This is a 17 billion active parameter model with 128 experts. It's the best multimodal model in its class again, beating out GPT 4o and Gemini 2 Flash across the benchmarks, and it actually matched DeepSeek v3 on reasoning and coding, but remember, it has less than half the parameters. This makes it the model with the best performance to cost ratio, with the experimental version of it actually scoring an ELO of 1,417 on LM Arena. Finally, the third one, Llama 4 Behemoth. The name is accurate. They claim this will be one of the smartest LLMs in the world, and they actually use this as a teacher for the other new models. Llama 4 Behemoth is also a multimodal mixture of experts model with 288 billion active parameters, 16 experts, and nearly 2 trillion total parameters. It outperforms GPT 4.5, Claude Sonnet 3.7, and Gemini 2 Pro on STEM-focused benchmarks such as Math 500 and GPQA Diamond. Unfortunately, it's not released yet, but it's going to be absolutely awesome when it does. So that's the 3 new models. You can download the Llama 4 Scout and Llama 4 Maverick models today on llama.com or Hugging Face, and of course you can use them with tools like OpenRouter and Grok. But what actually went into making these? The process began by feeding these models an enormous dataset, over 30 trillion pieces of text, images, and videos in 200 languages, essentially giving them more than twice the knowledge of their previous versions. A key breakthrough is what Meta called that mixture of experts design. Think of it like a company with hundreds of specialists, but for any given task, only the most qualified experts are called in. This makes the models much more efficient. Maverick has 400 billion total parameters. Think of these like its knowledge points, but that only uses about 17 billion at any moment. Meta developed special techniques to find the perfect balance in how quickly and deeply the models learn. They also maximized computing efficiency. When training their largest model, each graphics card was processing an astounding 390 trillion calculations per second, and by the way, they used 32,000 GPUs. After the initial training phase, Meta refined these models through a 3-step process, first teaching them basic skills through examples, then having them learn through trial and error, and finally fine-tuning their responses based on quality preferences. Perhaps most interesting though is how they transfer the knowledge from that massive behemoth model to these smaller, more practical models through advanced distillation. They effectively compressed Behemoth's 288 billion parameter capabilities into the more deployment-friendly architectures. This knowledge transfer enables the smaller models to achieve near teacher-level performance while requiring significantly less computational resources for inference. There we go and try these models out. I'm so happy that open models are absolutely crushing it. Let me know what you think in the comments down below, and as always, see you in the next one.